Here's how to graph any logarithmic function. So here's the first example that we'll be doing. We need to graph f of x equals log base 4 of x. So if you don't quite know what a logarithm is yet, then I do have a video on it that you can watch on the card on the screen right now. But I'll also quickly go over it here. Remember that a log is basically just the opposite of an exponent. What it's asking is what exponent do you need to put on the small number to get the big number. So because that would be if we're solving a logarithm, then that means our answer is actually f of x. So that's basically acting as our exponent. So f of x, or in this case, we could also call that y, is the exponent that you have to put on 4 to get x. So if we were to write this as an exponential equation, this is what it would look like. And as always, remember that up and down is y and left and right is x. So to graph anything, you can always just plug in numbers into x, see what you get out for y, and put them on the graph. So for example, if you put in 2 and then got out 3, then you would go 2 to the right because x is to the right, and then 3 upward because y is up, and then plot a point here, and then you would connect them up with a line. But just putting in any numbers all willy-nilly isn't going to be that useful because, like, for example, if you were to put in 3 for x, well, how are you supposed to know what exponent to put on 4 to get 3 without doing some calculator shenanigans? Well, with logarithms, there's actually a really nice trick that you can use to know what points that you should put in every single time. So here are the 3 points that you should always put in to graph a logarithmic equation. So first of all, you need to know what our base is. Our base is 4. So you should always plug in the base, you should always plug in 1, and you should always plug in 1 over the base. So in that case, that would be 1 over 4. And there's a reason for that, and I'll show you why. So first of all, let's go ahead and plug in 4 first, because I think it'll be the easiest to understand. So if we're plugging in the point 4 for x, remember that in parentheses it goes x then y. So we need to figure out what number we're getting for y. Well, if we were to plug in 4 for x, then what that's saying is what exponent do you have to put on 4 to get 4? Well, anything to the power of 1 is itself. So that means we would need to put an exponent of 1 here because 4 to the 1 is 4. So when we plug in 4 for x, we get out 1 for y. So we can now plot this on our graph. So 4 for x, that means we need to go 4 squares to the right, and then 1 for y, which means we need to go 1 square upward. And we will plot a point right here. So the second point that you should always plug into a logarithm is 1. And the reason for that is very simple. If we plugged in 1 for x, then what exponent do we have to put? Well, anything to the power of 0 is 1. So literally, no matter what number we have here for our base, then when you plug in 1, you will always get 0 because anything to the power of 0 is 1, which means our second point that we'll be plotting is 1, 0. So we go 1 to the right and 0 up or down. So our point is going to be right here. And now the third point that you should always plot is 1 over 4. So we're going to plug in 1 over 4 for x. Now, why are we plugging in 1 over 4? Well, there's another exponent rule that we can use here to make this really easy. Remember that anything to the power of 1 is itself, but also remember that a negative exponent flips the fraction around. So for example, if you had 3 over 2 and you put it to the power of negative 1, then you just flip the fraction. It becomes 2 over 3. So if we start with 4 over 1, because remember anything that's just a number, it's over 1. If we put it to the power of negative 1, then we just flip the fraction around and it becomes 1 over 4. So when we plug in 1 over 4 for x, we get negative 1 for y because our exponent here is negative 1. So if we were to graph this, we would have to go x is 1 over 4. So we're just going a fourth of a box to the right, so not that much. And then we're going 1 down because we have negative 1 for y. So 1 square downward, and we get a point right here. So really, that's all we need to graph it. You'll see that we have a curved line here. So the important thing to know for logarithms is that you're never going to go past this line. You're never going to touch this line. So it's just going to stay right like rubbing up against this line, and then it's going to go like this off into the distance. So there you go. This is the final graph of f of x equals log base 4 of x. All right, so here's our second example. We need to graph this logarithm, but what do we do if the base is a fraction? Well, we're going to do it the same way, but the points might end up looking a little bit different. You'll see. So first of all, we need to write this like our exponential equation. We just need to know what a logarithm is. Remember that it's asking what exponent do you need to put on the small number to get the big number. So we're taking our small number, and then we're putting some exponent, and remember that's f of x or y. F of x and y are like the same thing. And when we put this exponent on the small number, we get the big number, which is x. So now we need to know what 3 points we're supposed to plot, our little magic 3 points. So remember, we always plot our base, which is 1 over 3. We always plot 1, and then we plot 1 over our base, which in this case is actually 1 over 3. Now, whenever you have 1 over a fraction, it just flips the fraction around. So that means that this would be 3 over 1, or just 3. So let's just go ahead and plug in these for x and see what we get. So remember, when we plug in 1 over 3 for x, whenever you put something to the power of 1, it stays the same. 1 over 3 to the power of 1 is staying as 1 over 3. So our first point is going to be 1 over 3 1. And if we were to plot that, we have 1 over 3 for x, so we're only going a third of a box to the right, and then we're going 1 box upward, so right here. Next, let's plug in 1 for x. Remember that anything to the power of 0 is 1. So 1, 0 is going to be our next point. This is always going to be a point. So we go 1 square to the right because it's 1 for x, and then 0 for y, so we're not going up or down. And that means we're going to have a point right here, like always. And then finally, we plug in 3 for x. And remember that this is actually the same as 3 over 1. And we flip the fraction around. And the way you flip a fraction around with an exponent is by putting it to the power of -1. So that means that our last point is going to be 3 for x. And then when we put in 3 for x, we get -1 for y. So we have to go 3 squares to the right, and then we have to go 1 square downward. So it's going to be right here. So our difference from last time is because last time when we graphed it, it was going infinitely downward this way, and then it went upward, and then eventually went infinitely to the right. But this time, instead of coming from the bottom, we're coming from the top. So it's going to stay infinitely close to 0 at the top, and then it's going to keep sloping downward like this until we go infinitely to the right, just like last time. So this is our horribly drawn graph of log base 1 over 3 of x. So now you know how to graph just a basic logarithmic equation where you have log base something of x. But what if you have these extra things attached to it? Well, these are called transformations, where we basically have what we were graphing earlier, which is just a basic log base something of x, and then we have these extra things added on that are going to do something to the graph. So these transformation things are done with like basically every type of graph, with parabolas, with exponential graphs, with square root graphs. So I have a full video on transformations if you want to watch that to see all the different things that can change a graph. But I'll just go over here how to use them with a log equation. So basically the point of transformations is that it would take a long time to keep plugging in numbers for x and then see what you get for y when the equation's more complicated. So instead, what we can do is we can just figure out what our parent graph is. So our parent graph is just the basic equation. In this case, our basic equation is log base 4 of x, because that's the kind of graph we were doing before. So our parent graph is f of x is equal to log base 4 of x. So we're going to take our parent graph, we're going to graph it on our graph like we did before. And then we just need to figure out what this 2 is doing and what this plus 1 is doing to the graph, and then just make those changes. So I'm going to graph log base 4 of x just the same way we did before. So if you don't quite remember how to do that, you can go back to the beginning of this video. So now our goal is to just figure out what the 2 is doing and what the plus 1 is doing. So I'm going to show you what the plus 1 is doing first because that'll be easier. So whenever you're adding on a plus or minus number at the end of the graph, what you're really doing is just taking what you got for y, or f of x, and then adding 1. So when you add 1 to y, remember y is up and down, so you're just moving the whole graph up by adding numbers, or you'd be moving it down by subtracting numbers. And if you watch the transformations video, you'll see that there is a difference if there were parentheses around here. If there's parentheses, you'll move left and right. And so if it was positive, you would move to the left. And if it was negative, you move to the right. But in this case, we're moving up. So what you would do is you would take each of these points and move them up 1. So you would take this point and move it up here. You would take this point and move it up here. You would also take this point and move it up here. And then you would just redraw your graph. So there we go. We've now increased everything by 1. So the graph has been moved up 1 square. And now we can figure out what our 2 is doing. So this just says 2 log. There's no sign in between the 2 and the log. And remember that when there's no sign and things are next to each other, that means multiplication. So we're taking what we got and we're multiplying it by 2. So basically the way that we do this is we multiply everything how high up it is by 2. And for how high up it is, we're actually going to be using this right here as like our floor, because that's where it was originally before we moved it up. So this point here that's already on the floor, that's just going to stay the same because it's 0 spaces up and 0 times 2 is 0. But this point here is going to change because it's 1 square above the floor, as we're calling it. And when you are multiplying it by 2, 1 times 2 is 2. So this little point here was 1 square above the floor. Now it's going to be 2 squares above the floor. Now remember that this point was staying the same. And then we have this point here. This one, it was 1 square below. So now it's going to be 2 squares below. And so we're going to put a point right here. So we're just going to take all of these black points that I've drawn here and we're going to connect them up. So I know this is looking a little complicated, but remember that the green part was just our parent graph that we started with, and the purple was just us doing our work in the middle. So everything except for this black line, we can actually erase. And there you go. This is the final graph of f of x equals 2 times log base 4 of x plus 1. There's one other transformation I didn't talk about in this video, but it's in the transformations video if you want to watch that. It's if you have a negative sign in front of the number you're multiplying by. In that case, you would just go ahead and flip everything upside down. So now you know how to graph any logarithms, including ones with transformations in them. But along with graphing, it's also important to know how to solve logarithms. So if you want to go learn how to do that, you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.